Welcome to Summarize Science. Today we are looking at a fascinating study about how the saltiness of oceans and the tilt of a planet can make distant worlds habitable. Usually, scientists look primarily at greenhouse gases like carbon dioxide to decide if a planet is warm enough for liquid water. However, this new research shows that ocean salinity and planetary tilt, also known as obliquity, play a massive role that has been overlooked. The researchers investigated how these two factors jointly impact the climate of Earth-like planets orbiting Sun-like stars. The team used a sophisticated NASA climate model called ROC 3D to run their simulations. They discovered a synergy where salt and tilt combined have a greater impact on a planet's temperature than the sum of their effects in isolation. This happens because of the ice-albedo feedback, where less ice leads to more absorbed heat, which in turn melts even more ice. On this page, you can see Table 1, which summarizes the 61 successful simulations they performed across various salt and tilt levels. The results showed that even planets receiving much less sunlight than Earth can remain ice-free if the conditions are right. These maps represent the annual mean sea ice for different scenarios on a cold, Archean-style planet. The green borders highlight worlds where more than 10% of the ocean remains ice-free and potentially habitable for life. Notice how the ice cover shifts and shrinks as the salt content increases from left to right. Salt in the ocean acts like antifreeze, lowering the freezing point of the water and making it harder for ice to form. Meanwhile, the tilt of the planet determines where the sunlight is most concentrated throughout the year, as seen in these latitude charts. At a high tilt, the poles actually receive more energy over the course of a year than the equator. This can lead to equatorial ice belts where the middle of the planet is frozen while the poles are open water. The researchers found that high salinity can narrow these ice belts significantly, increasing the area where life can survive. The study also looked at something called fractional habitability, which measures the percentage of a planet's surface that can support life. They mapped out habitable regions for both the oceans and the continents based on temperature and precipitation. Even on very cold worlds, a salter ocean can lead to more rainfall and warmer land near the equator. This work has huge implications for the history of our own home planet, Earth. Early in Earth's history, the sun was much dimmer, and the planet should have been a frozen ball of ice. The researchers suggest that a salter ancient ocean may have helped prevent a global freeze-up, allowing life to evolve sooner than expected. This means when we look at distant stars with telescopes, we cannot just look at distance. We must consider these hidden factors. High salt and high tilt might be the secret ingredients that make a cold planet a perfect home. To recap, the combination of ocean salt and planetary tilt creates a powerful warming synergy. This discovery expands the habitable zone and gives us more places to look for alien life. In the future, astronomers will need to find ways to measure these properties on exoplanets to truly understand their potential. Thanks for watching Summarize Science, and stay curious about the mysteries of the universe.